Module 1, Introduction to Computer Networking. Computer networking is the connection of devices for the purpose of sending and receiving data and sharing resources. Cisco defines computer networking as connecting computing devices such as laptops, desktops, servers, smartphones, and tablets, and an ever-expanding array of LOT devices such as cameras, door locks, doorbells, refrigerators, audio-visual systems, thermostats, and various sensors that communicate with one another. Why so complex? Networking appears to be a complex subject due to the huge number of products, technologies, and interconnection systems in use, in addition to the variety of terms used to describe those products, technologies, and interconnection systems. Take, for instance, the word memory. What do you think of? What comes to mind when you hear the word memory? Memory is defined as a physical device capable of storing data. There is a temporary memory like random access memory, RAM, which includes dual inline memory modules, DIMM, rambus inline memory modules, RIMM, single inline memory modules, SIMM, small outline dual inline memory modules, SODIMM, static RAM, SRAM, dynamic RAM, SDRAM, and non-volatile RAM, NVRAM. You'll see some of these are listed here in the list above. There are three basic types of ROM: programmable read-only memory, erasable programmable read-only memory, and electronically erasable programmable read-only memory. Those are listed here in the bottom. RAM and ROM are considered primary storage, while HDD, the hard drive, and solid-state device and hybrid, magnetic tape, optical discs, and flash drives are considered secondary storage. How many terms are used to describe flash drives? Thumb drives, USB drives, jump drive, pocket drive, pen drive, disk on a key, memory stick, USB key, data stick, and finger stick. Lots of names for the same thing. In addition, there's a special purpose memory such as cache, virtual memory, Windows RAM, graphic RAM, registers, and many more. Communication requires interoperability. Computer networking is the interconnection of devices for the purpose of sharing resources. Misunderstanding is a breakdown in communication, and communicate without misunderstandings is called interoperability. Since multiple users and entities are involved in communication, there must be an agreed method to handle all the details, such as format and meaning of messages. Communication protocol, network protocol, or simply protocol, refers to a specific specification for network communication. A protocol also specifies the details for one aspect of communication, including actions to be taken when errors or unexpected situations arise. Computer networking in this course will be explained using the Layered Transmission Control Protocol Internet Protocol reference model, as you can see right here in the blue. The concept of a layering model is presented along with a 5-layer transmission control protocol, Internet Protocol, or TCP/IP reference model. This model is used to help reduce communication complexity by separating the aspects involved in communication. An example of layering are the employees of a restaurant. There's a host to seat you and your party, a waiter to take your order, a chef to cook your food, and a cashier for you to pay the bill. The busser to clear the table, and a dishwasher to clean the dishes. These employees must interact for you to enjoy a meal. The dishwasher must know where to store the dishes so the cook can plate the food and the glasses so the waiter can serve drinks. However, if an employee quits, such as a chef, the owner has to hire a new chef. The new chef doesn't have to know the details of the host, or waiter, or cashier, or dishwasher. You don't need to replace all employees or change the tasks they perform when a new chef is hired. In a restaurant, by separating the tasks, the employees focus on only their job while still working together to provide a service. The same is true with networking protocols. Each layer in the protocol suite performs a specific function, and you can replace the protocol in the suite without having to change other protocols. Layered approach is the hierarchical way to address all required technologies and devices in effective communication. It allows vendors and manufacturers to build and design specific application and hardware in one layer for a particular purpose without affecting the entire network protocol stack. TCP/IP model uses this approach. It divides the entire communication process into layers, and each layer describes a particular functionality along with the protocols and devices that they are required to perform the function. The application layer is where users interact, such as where you use a web browser to contact a web server. The Protocol Data Unit, or PDU, at Layer 5 contains control information, and user data is called data. Some of the protocols that reside on the application layer are Hypertext Markup Language, Hypertext Transport Protocol, email protocols such as Simple Mail Transfer Protocol, Internet Mail Access Protocol, Post Office Protocol, plus Uniform Resource Locator, Domain Name Service, and File Transfer Protocol. Examples of network applications are email exchange, file transfer, web browsing, telephone services, and video teleconferencing. The transport layer provides application-to-application communication by using port numbers. An example of port numbers are contact to web server on port 80 or 443. Email clients talk with an email server on port 24. The PDU is called segment. There are two main protocols at Layer 4. TCP, which forms a connection before data is transmitted. It provides full duplexing, one-to-one communication, and guarantees error-free delivery. UDP is lightweight protocol. It does not form a connection before transmitting its message and has low overhead. TCP includes reliability and flow control, while UDP does not. Most applications use the TCP at the transport layer because it guarantees every bit sent is received in the exact order at the destination device. This is extremely important in banking, online shopping, and other applications that require the communication stream to provide exact data transfers. UDP is used in multimedia. For a realistic experience, you do not want to halt the game you are playing or the video you are watching to wait for a corrupt packet to be retransmitted. It is acceptable to see a bit of pixelation or hear a pop or click instead of the application stalling. Layer 3, the Internet layer, connects hosts on different networks and is responsible for routing of data packets. The PDU at this layer called a packet or datagram. Routers sit at the Internet layer and moves data across the series of interconnected networks. Packets are routed through the Internet by using logical or virtual addressing. Addressing is a critical component of the Internet, and all host computers must use a uniform addressing scheme. Current versions of Internet addressing are IP version 4 and IP version 6. Other protocols on the Internet layer are Internet Control Message Protocol, IPsec, and router protocols such as intermediate systems to intermediate system and gateway to gateway protocols. The device that sits at layer 3 is a router. The network interface layer provides connections between hosts on the same network and for accessing the physical medium. Communication between hosts use a physical address better known as the Media Access Control or MAC address. The PDU is called a frame. Devices on layer 2 are switches, access points, and the network interface card or NIC. Some of the protocols that reside on the network interface layer are Ethernet, ARP, IEEE 802, including the wireless protocols 802.11, asynchronous transfer protocol, and spanning tree protocol that prevent loops from occurring when switches are interconnected. By the way, ARP is layer 2. The reason being is that broadcast is sent on layer 2 and ARP will normally not transverse to layer 3. However, it can provide extra features to the layer 3 protocol. The truth is that not all protocols fit the TCP IP model exactly because it's just a model. Data is physically moved across the network interface at layer 1, the physical layer, and actually sends it out over the network. The PDU is called bits or bytes. The physical layer is responsible for encoding and the signaling functions that transform the data from the bits that reside in the computer to signals that are sent over the network. The electrical and physical specifications for devices such as cables and connectors are established here. Devices that sit at the physical layer include repeaters, hubs, modems, media converters, and cables. Some of the protocols that reside on the physical layer are digital subscriber line, synchronous optical network, T&E service carriers, Bluetooth, and universal serial bus. We've briefly covered the 5 layers of the TCP IP model. Now let's look at how data is assembled for transport across a network. We'll start with the headers. Headers add information to the front end of a chunk of data so that the data can be correctly interpreted and processed by the network protocols. First, data is created in the application layer. The transport layer header adds port numbers and sequencing if required. IP addressing is part of the header information added at the internet layer, and MAC addresses are included in the network interface layer. The physical layer typically doesn't add a header, but translates bits into signals. The packet that travels across the network contains the data plus all the header information needed for processing the packet. The payload consists of the information passed down from the previous layer, while the header contains layer-specific information needed to accurately process the packet. At the application layer, the payload is the actual data produced by the application, such as when requesting a web page. The data created at the application layer is then sent to the transport layer, where it becomes the payload of layer 4. The transport layer is an application-to-application layer. It adds port numbers in the header information. Then the segment is sent to the internet layer. This information sent from the transport layer becomes the payload for the internet layer. The internet layer adds IP addressing, among many other pieces of processing information, in the layer 3 header. The packet is then sent to the network interface layer, where it becomes the payload in layer 2. The network interface adds information that permits the network interface card to process the packet destination MAC address, source MAC address, and ether type, plus error correcting code. This frame is sent to the physical layer where the ones and zeros are converted to signals to be transmitted across the network and to its destination. The process of combining headers with the payload is called encapsulation. Encapsulation describes how data is packaged and how the information is passed between layers. Data is created at the application layer, right up here at the top. And that data is sent to the transport layer, where it becomes the payload at layer 4. The transport layer adds port numbers in the header and sends that segment to the internet layer. This information sent from the transport layer becomes the payload of the internet layer. The internet layer adds IP addressing and other layer 3 header information in the header. The packet created at the internet layer is sent to the network interface layer, where it becomes the payload in layer 2. The network interface adds information for the network interface card to process the packet and sends this frame to the physical layer, where the ones and zeros are sent as signals across the network to the destination. When the communication is received at the destination computer, the process is in reverse. Layer 1, the physical layer, passes the incoming frame to the network interface layer, where the NIC examines the frame and then sends the payload to the correct module for processing at the internet layer. After process, the layer 3 header is stripped off and the payload is sent to layer 4, the transport layer, for processing. At the transport layer, the port number is extracted and the data is sent to the application layer for processing. When a response is sent, this entire process is repeated. This module explains that network communication consists of sending and receiving data, plus allows for the sharing of resources. The TCP/IP module is introduced explaining the 5 layers. The application is where the user interacts with the applications reside. Some applications that sit at this layer are HTTP, HTML, URL, DNS, SMTP, IMAP, POP3, and FTP. The transport layer allows applications to communicate using port numbers. The internet routes the packets through the internet using IP addressing. The network interface uses MAC addresses to provide connection between devices on the same network. And the physical layer is responsible for transforming the bits that reside in the computer, the signal that is sent over the network. Headers tell the system how to process the data. Encapsulation describes how data is packaged and how information is passed between layers.